Hello and welcome back to the Renewables podcast. Before we get into today's topic and discussion, I've got Sam with me again. And how are you doing, mate?
Yeah, I'm really good, really good. Looking forward to getting into this one. It's going to be an interesting one.
Yeah, the topic today is going to be exciting, I think. But how things have been going for you in the business anyway, before we get to that?
Yeah, really good. Businesses ups and downs, as most people watching probably will know. We get a lot of installers listening, and the business. 1 minute you can be on top of the world, next minute you can be down in the dumps and up and down. I'm on the higher part of that at the minute. We just had a confirmation, which has been good, a hard-won one as well. So it's nice to come out the right side of one of those.
Yeah, that's why I mentioned it, because I think it's one of those things to celebrate. We often forget that as business owners, that when things go wrong, we're like, oh God, and dwell on it for ages, and then you get something over the line that's really good, and you've forgotten about it 5 minutes later.
Yeah.
So it's great news for you.
Right.
Great news for you tonight before we grill you about this cable. So for those of you who don't know, Sam, in conjunction with Doncaster Cables, invented a cable. It was last year, wasn't it, that it came out?
Year before, actually.
Was it? Did
we
it come out?
unveiled it. We unveiled it at Solar and Storage Live, not this time round, the year before.
Okay.
So it'd literally just been made then. Yeah.
So it's come out in its original form that you've got there in your hand, and there's a new variation on it that the thrust of the conversation tonight's going to be about. But for those who don't know, do you want to explain what the original variation was?
Yeah. So PV Ultra is basically it's easy to explain. Anyone that's watching this that hadn't seen it or listened to this is basically the first multi-core DC cable that you can get. So it basically avoids the need to have trunking or conduit maybe up the side of a building or however you're going to contain those standard PV cores. And it basically came from, I went to do a survey at a property. It was a nightmare cable run for the DC. So I rang the absolute legends that are Doncaster Cables, and I spoke to Neil Mallinson and then Aaron as well about if there was a cable out there that would allow for using basically one cable with multi cores for DC, because a lot of our systems are single or double string, so we need 2 or 4 cores, and running it in conduit is fine, but unless you spend a lot of time doing it, if it's a nightmare run, then it looks like a dog's dinner, even if you spend a long time doing it. So the idea was to try and develop a multi-core cable that basically was just like clipping an armoured. And there was during the development of this, it took about a year to develop with Doncaster Cables. During that development, I believe it was the IT and came out and kind of withdrew some of the comments that have been made about steel wire armoured being able to be used, and their argument was it was never really allowed to be used apart from if it was like a single core DC cable because of the double insulation side of things. So that kind of helped PV Ultra push forward. But the reason that we wanted to mention that I was involved with this wasn't because I wanted like a vanity thing. It was because so that if we're ever promoting this cable during the podcast, you know that I may have an ulterior motive to that. Because I've got an agreement with Doncaster Cables around the cable. So that I wanted to make that completely clear right from the start, so that it's not just like an advertising piece for it. So in essence, what PV Ultra is, this is the 2-core version. This is the 4mm. There's like 4mm, 6mm, and 10mm now. But this is double insulated cable. So this is like the normal PV cable you get on your 50 meter or 100 meter drums, but it's just coloured in the right colours for polarity. So if you've got 100 meters of that, you can make sure you get the right cable at the other end. So you can clip that surface, but then it's got a bedding on it, and then it's got an outer sheathing on it as well to give it that protection, that UV protection. And there is a draw cord in as well, because you might need to obviously strip like 10 meters of that to get, for it to go to each end of your array. But the variation that you were talking about was an SWA variation. So on top of the bedding underneath this sheathing, like a normal armoured cable, the Doncaster Cables have now brought out an SWA version, which was discussed right at the start of us releasing this cable. But being honest, I wasn't sure how to approach it. And that's what this conversation is about. And Doncaster Cables, quite rightly, I think, to be honest, decided to release the SWA version because they were getting asked for it. But also, their absolutely 100% correct argument is once the product is out there, it forces the conversation. And I aren't sure that we'd be sat here talking about an SWA like a steel wire armored DC cable unless there was one out there on the market. So props to them for taking that jump and doing it. But when we initially released it, we wanted to just keep it in its simplest form to get the idea out there and try and convert people to using the cable, and then take advice from customers and other people on what they wanted to see. And one of those things was an SWA version. And that's what we're going to discuss today, because it raises some questions.
It does. I mean, good innovation solves problems for us as installers, and the original form of PV Ultra solved that. I mean, the best will in the world when you're installing long runs of conduit, even with your expansion spaces that you put into there, eventually you get buckling. I've had it on jobs where I think we've done a great job, installed all this conduit outside, and sometimes that can still buckle. It's where it expands in sunlight. For those who don't know, it can get quite brittle as well in winter as it thins because of that. You get cracks and breakages. Having a cable that's designed for that environment removes that problem. So these are on long runs. We've just done one recently at a Kennels and Cattery. I think it was a good 50 metres of exposed run. You've got the labour installing all the conduit and then drawing cables through it as a separate side subject. But equally, that exposure over what could be 20 years, where a cable, once it's up there, that's just it, sitting it. It's just done its job. And it's the same with the SWA variation. And that actually was quite exciting to me when I saw that come out. I was like, oh, this is interesting, because we've had the discussions around steel wire armour and DC and the fact of no double insulation between the cores and also to the earth of that cable. And all of a sudden, well, that problem's been solved now, because we've got cores that are insulated and we're separate from the supposed earth in that cable as well adequately. So can we use this? What are the actual requirements? You start delving deeper then, and you're looking at your kind of fault protection, your method of protection in the design, be that ADS as we're used to in AC, or your reinforced and double insulation as we've got with DC. And it brings some head scratching to the table. But these are things that installers want to solve. Of the past, I don't blame installers who've put steel wire armour in the ground, running DC in fields when they've got arrays going out. Because back then, if you rewind 10 or 15 years, there wasn't these kind of conversations happening. You were working with a reg book, interpreting it in your own way. And the chain of thought and logic would tell you, we use this in AC. It's how we do it. It's a safe way of doing it. And you can come to the wrong conclusions, not through somebody trying to cut corners or save money, as we often see in some of the bad practices of industry. It's just from misunderstanding the intent of regs. So I think as we are today, we shouldn't judge too harshly of what's happened before, but we want to get this particular cable type installed the right way. It's not to Doncaster Cables to tell us as installers how we should fit that.
No.
It's not to them to decide what the use point for it is. They've put it to market, and we need to consider it as designers. And I think there is a good case to use that cable. Maybe not in the way some of you were thinking right now, but I definitely think there is.
Yeah, I think there is as well. And the reason I've got kind of my head in my hands a little bit is because this is bringing back a lot of the conversations that I had with Doncaster Cables around like 2 years ago when we were chatting about this. And they were asking me the questions of, well, what would you do with the earth? Or what would you do with the armouring? Would you earth it? Would you not? And like you say, it's not up to them to say what you would and wouldn't do. It's up to us as the designers and installers of these systems. And that's kind of what I was to this whole conversation. And quite honestly, I didn't have the answer. And that's why we didn't release it at the point of initial release, because we didn't have the answer. And I knew that was going to be a massive question, like it is now, as to what we actually do. So I didn't want that to affect the release of the cable. But then obviously Doncaster Cables have released it, and I completely back them releasing it because it has driven this conversation. But I think one thing that is interesting is seeing the armouring as something that is earthed is an interesting one, and whether or not you just use that for mechanical protection, and because we haven't necessarily got like the automatic disconnection of the supply because it's on the DC side. So I've been frantically doing some notes and things around this, but I think probably an interesting place to start is where would you, when you saw that cable out, where were you thinking that application of that cable would be?
The big thing for me was around rodent damage. So especially on ground mount arrays, I'm not so much considering the cable in the ground. We've gone out to a few jobs local to us where a lot of the DC cables have been rinsed by rodents at ground mount level, be that rats or squirrels or whatever. And they're just left there until somebody comes along to see them or encounter them. They're not entering a fault state. They still continue to function. And is that safe because there isn't a mechanical protection on that cable? And how would you achieve that? We're going to start putting metallic conduit over your strings. You still end up with that metal part to stop the rodents chewing and nibbling. So that was my main consideration with that. I think with a buried cable, most of us now would be using a duct anyway. So you'd use one of your 750 N-rated ducts, and you can just put normal cables through that. You don't need a steel armouring on there to adequately protect it when it's buried in the ground. There's a great article from Michael Peace at the IET and Wiring Matters that explains ducts and the type of ducts you can use, the depths they need to go to when you can bury cables direct. And with your AC stuff, traditionally you'd look to bury a cable direct if you was trying to get a bit more out of it. So you can lose some of the derating factors if you put it straight into the mass of earth, because obviously it will dissipate the heat more easily. But even now, if you're going to the trouble of digging someone's garden up to draw a cable to a garage, to the house, you're going to put a duct in, aren't you? So you've got that possibility to draw other things through in the future.
Yeah.
Where you might not do that is in large field arrays, where having the duct installed can become quite costly. Somebody might be looking at molding or even peeling back the earth as you go. You've seen these machines now that you can get that just put the cable straight in the ground.
Yeah, it's like a plough, isn't it?
Yeah, there's all these options that those kinds of installers might be considering. But one thing I would say is any steel wire armour, as far as I understand the regulations, that's buried directly in the ground, it must be earthed. That's a shall in the regulations, is my base understanding. Maybe those of you watching have put me right on that. So if you are burying this cable without any duct into the ground itself, whatever you think about ADS or the reinforced and the double installation, if you want to comply with BS 7671 and not have a deviation on your certificate, you would have to earth those armours. If you didn't, you could choose to do that. You could argue that it's a safer situation to be in without it earth, but you'd put that as a deviation on your certificate that is to the guidance in the book of how those certificates should be completed.
Yeah, one thing that I've been preparing was a little bit like, because I've looked at this as well, and again, I'm not going to pretend I've got the exact answer, but all we can be guided on is our technical judgment and what we have in front of us in terms of information. And one of the things that we've got is we've obviously got the code of practice book for grid connected solar PV, and it mentions in here about burying cables. This is on anyone that's got this at home. We're back over at Regulation Corner, page 62 of that book. We've got cable installation, section 5.10.3. So don't turn off. I'm not going to be doing regulations all the time. But this one is, this section here is about buried DC cables. So I'll just get the right part here. So there's a bit here. It says solar PV cables. So the normal solar PV cable, like the internal cores of PV Ultra and the normal cable that you would buy, shall not be directly buried in walls or otherwise directly encased in the fabric of the building. Where burial in walls cannot be avoided, so this is obviously walls at the minute, but it goes onto the ground, conductors shall be suitably protected from mechanical damage, and a plan showing cable location shall be provided in the System Operation and Maintenance Manual, so O&M Manual. Solar PV DC cables buried in the ground shall be buried in the ground at a suitable depth considering the use of the area which are buried, so section E2, which must give some guidance there. Protection against mechanical damage and impact in accordance with Regulation 522.8.10 of BS 7671 by installation within an underground conduit meeting the classification of N750, which you mentioned, Mark, according to BSEN 6. Well, I won't read that because that's but conduit systems for cable management. So basically, the BS part for conduit and conduit systems. And then C for that, part C would be have additional measures taken to limit access to rodents, rabbits, squirrels, etc. at the open ends of the conduit as they enter/leave the ground by use of a suitable filling material meeting the requirements of the manufacturers of the conduit and cables installed within it. So there is some general guidance there for burying DC cables. So just to go over them again, just like quickly. So buried in the ground at suitable depth, encased in a N750 conduit or duct that is to that level, and have the ends basically adequately protected.
Yeah.
Basically just to protect the cable. because this here is looking, when this has been written, it doesn't know anything about PV Ultra, and in a way it doesn't really matter. It's protecting that cable from rodent damage with sealing the ends, from crushing through having the N750 duct, because I believe that's the newtons of applied pressure, and then at a suitable depth, so it's not going to get ragged up by a tractor that ploughs that field or what have you. So they're the general. There's a bit more on that, but they're the general rules of thumb. And we've done a big ground-mounted system, 208 panels in the field, and PV Ultra went out at that point, unfortunately. It was actually in the development, and I was like, I wish we could get some. But I used N750 duct, and it was buried at, like, the customer was burying it, and he said, how deep do you want it? I went, how deep can you get it? And he said, well, what about, like, 1.5 meters, 2 meters? And I was like, if you can dig it that much. And he basically had he was a house builder, and he had a proper trenching machine, and he basically set it to the depth and just ragged it in. So, and we had a duct in there, but it was standard PV cable, 10 mil. And so, yeah, that was a massive consideration on it, and that's where I went to the book and learnt about that. But yeah, so it's quite clear on that what we have to do for those buried cables. But obviously, that section doesn't know about PV Ultra, and does that affect what we have to do, or does it not?
I think normal PV Ultra, you'd be fine to draw that through the duct, but you end up in the same situation as the cable exit and enters that duct. People are worried about rodents getting in the ducts and nibbling all your cables, but they still exit and enter the array framework and all the rest of it. And for some reason, they seem very attracted to chewing insulation on cables. I don't know what they put in it, but obviously it tastes nice if you're a rodent. So if you can take an armoured PV Ultra right up to either a local isolator or a splitter box, or as close as you can to your first panels. Obviously, the cables between the panels, they're still, largely you can cable tie them all you like, but they're going to have a bit of exposure, aren't they? If a determined animal wants, they'd get to them. But, make that as difficult as possible. And if you're on a roof-mounted system, we've got all of the pest fix netting around them, and you're trying to keep them out of that area anyway. So there's a good argument for it that they can't chew through metal. So your double insulated reinforced cables inside that are going to be well protected. And the other issue is you would have had drawing your cables through that duct for your array, Sam, that you can pull your loose strings through, and if you use a large duct, 99 times out of 100 you'll not have a problem. But sometimes you can get snagging in the duct where the cable will rub against each other, and you won't ever know, but that outer insulation's been rubbed off, or you've got a nick or a crack in there. Moisture gets into your duct somehow. It could have got compressed against a rock if it's not been bedded in quite right. You end up with flooded ducts, and these cables can suffer damage, which can cause shorting out. I've seen the footage that Jamie Blayton shared before of some of these large field arrays where the cables have rubbed apart in the ducts. They've ended up shorting out, and no one ever knows about it. They keep working. There's no real fault measure that notices those things because there is no metallic way for those electrons to interact with each other. If they're all positive cables, for example, you're not going to enter a fault state. If you've got a path in there, then you will enter that fault state before there's somebody coming to interact with it. I think the big benefit of having them inside an armoured cable, even in a duct, is they're well protected. If a rodent gets near them, they can't encounter those cores. If your cable gets damaged while it's been drawn through, chances are it works as just a single one, unless you're drawing a few PV Ultras through together. But even then, you've got the bedding, you've got the outer insulation, you've got the double reinforced insulation. It's all as well protected as it can be. And then if you've got that metal jacket in there, if the worst has happened, and the big worry is that the DC voltages end up on the earthed armours and then track back to the wider earth in the installation. If you've got that path, optimizers, which isn't a method in the regs that's acceptable for determining a fault happening, will see it and will shut down the generation at source. And this is where the regulations of things lags behind the technology that's out there. They don't like that. They don't like these electronic RCDs that are in EV chargers. And they're valid concerns, maybe. But it doesn't change the fact that if you've got an optimizer on an array, it will see that insulation resistance breakdown in a string if there's somewhere for those electrons to start bouncing around.
Yeah, absolutely. And I think you're quite right. The regs do tend to lag behind innovation. It happens in everything, not just cabling and what have you, equipment and what have you. And I think as we saw with the whole Zappy thing with the RCD built in, because it was not specifically a 61008 or 009 device, it's then not technically to regs. It's probably even better than one of them, to be honest, but it's not been tested to that. I feel like what we do have in a lot of inverters is the ground fault circuit interrupters, so the GFCIs or GFIs. And so that was something I was looking at, and I was thinking, is there a standard for this? Is there a type test that you can, because ultimately we'll get back into this same argument where we're trying to protect a cable through like a shutdown, but then we're only shutting down that cable at the inverter unless we go to optimizers.
Yep.
So it is a bit of a quandary as to which way you go with this whole SWA thing. So in your description there, Mark, are you on the side of earthing those arm rings then? If it's going because of that whole thing around that steel wire arm, it has to be earthed if it's going in the ground.
I would leave them as additional mechanical protection,
Right, okay.
and I wouldn't earth them. I would install the cable in a way that there was no access to those armours whatsoever. Yeah. So they're within the jacket of the cable, whatever glands you're using, make sure that nobody can touch them, interacting with the system, basically. But I would want them there for the mechanical protection for rodents, and also as an unsupported fault path. So it's not something that the regs would look towards being a way of fault protection, but understanding how optimizers work and the arc fault protection and GFCIs in the inverters, using that to enter a fault state more easily. Because when we look at ADS, is what we're trying to do is grow a magnitude of fault to limit the fault duration to as small a time as possible. So we want a large fault to occur, and we want that to be taken away as rapidly as we can do that. That's the traditional method. I think with the PV side of things, the way it is at the minute, we have those faults sitting there indefinitely that are not been detected, that are not been shut down. And there's a way and a method for us as installers to get to that state more quickly that means we have to deviate from the regulations. So in that approach I'm suggesting, there's an argument that you maybe would have to deviate in what the regs are intending. You know, I would argue that actually I think I can satisfy the regs because I'm using a 750N duct. I wouldn't bury that cable in the ground and not have the earths armoured. I wouldn't bury a PV Ultra SWA direct in the ground under any circumstance at the minute. That isn't an installation method I would use. But in using it, you can enable those optimizers to be triggered by the inverters. So if we're talking about Solar Edge or even Tigo, I always pronounce it wrong, they can be activated and shut down at source. So we've entered a fault state, we've had a magnitude of fault, and it's operated a protective measure to take that away from the installation aside from the source. You know, we've got there. We've made a safer condition than if we follow the regs to the letter with the technology that's available.
Yeah, so in that example there, then you're saying that you're deviating from regs because you are not earthing the armouring of that.
I don't think it would be a deviation if I was in a 750N duct.
Right.
It would be considered mechanical, additional mechanical
because
protection.
It's 750.
So if we had your duct in the ground, if we imagine it in a traditional sense of an install, you got your 750N duct, and I managed, because I'm a really good shot, to put some 20mm steel conduit through it. And then I managed to put my PV strings through that as well. The conduit would live inside the duct, so it's not an accessible conductive part. It's not extraneous because it's not introducing the potential anywhere. And I'm just using it for mechanical protection to stop squirrels and rabbits and rodents chewing those DC strings in the ducts. It's impractical. You'd never be able to do it.
Yeah.
I would view that armour on the PV Ultra SWA as the same. It's not accessible. I'm keeping it inside its insulated jacket. I'm making sure the glands I'm using don't allow access to it. There's an argument that you could earth the armours with it in the duct because it's not buried direct in the ground. But you have that other issue then of not introducing DC voltages into the earth system. I mean, we're taking out of the equation the whole capacitive and parasitic coupling and the fact we're looking at earthing arrays anyway now because of the way some of these inverters work. You know, whether we like it or not, we've got AC and DC systems blending together. It's already happening. So this whole conversation is maybe irrelevant because I think we're moving towards times of earthing PV systems more widely anyway. But as it was, I would use it unearthed in a 750N duct and then keep those armours away from any access and just use them as a mechanical protection.
Yeah. No, I mean, that's the side of the fence I fall on as well. And that felt like the right way to do it because it's it's, are you introducing a problem by earthing those armourings anyway? I mean, I'm really in two minds about all of this, because one of the things that I was looking at in preparation for this was, one of my things here is, as a little prompt for myself, should we be bonding panels now to allow for like a nice fault path to occur, so that these problems aren't just kind of island, just sat there waiting for, Jim the gardener to come and cut around those panels, cut the grass around those panels, or whoever it is coming to wash the panels, or what? Should we be trying to introduce a really nice fault path for some of this stuff to work, if we can rely on some of these GFCIs, and if there's a way that we can actually shut down the system? Now, in my view, every property should have optimizers, regardless of shading. It's one of the massive mis-selling things, I think. Not mis-selling, but it's focusing on one perk of having optimizers, whereas I feel like all of these other questions can be solved by trying to shut down at source that that generation point, which are the panels. If we can't have a reliable device that shuts those panels, that shuts that system down in the event of some leakage to earth, because ultimately that's going to be the frame of the panels, or the solar skirt, or whatever else it's in contact with.
There's two fault paths, isn't there? One is you can have the big one that people seem concerned with is the DC voltages ending up in the AC earthing system. But the other way around to that is, if you get a fault in the AC system, it might not clear quickly enough. If, I don't know, the MCB's gone faulty or whatever, and that fault could hang on that earth for longer than is needed. And it could be that person cutting the grass is unlucky enough to be in contact with some earthy part that you've introduced through your PV Ultra SWA and become the fault path. That's a concern people have, and mitigating against that is quite difficult unless you start looking at the whole expanding the equipotential zone to incorporate your ground mount PV array or your shed array. And we have that with garden buildings as it is already. When we're expanding the equipotential zone, or are we exporting our PME earth to a shed, and the worries there that somebody could be outside that building on the massive earth and there's a fault condition or whatever, and they can have an electric shock, or it could be that you've got a diverted neutral current that starts playing havoc as well. There is all these kind of things, and by nature a ground mount solar PV array is very earthy anyway, because the frames are all in the massive earth, usually on very good deep strong piles or concreted in foundations or ground screws, and it's all clamped together onto the solar panels. And for as much as the manufacturers say the class 2, it's on the back of every solar PV panel. If you look, there's that class 2 icon. We know through capacitive coupling, and I know from the stuff I've encountered on installs and checks I've done on my own system, that those joined earthing systems are happening, through the way inverters work and the way that solar panels do allow moisture into them, and you have that capacitive coupling or parasitic coupling, however you want to term it. So it's all considerations. I do think we are moving towards times where the regs will tell us that basically every PV array and panel system should be earthed to an electrode local to it if it's ground mount, alongside the actual piles and ground screws. And then your roof systems, at the minute, it's kind of optional, but I think they will be telling us you need to be earthing these to cover off other things away from the PV Ultra SWA aspect.
Funny you mentioned this, Mark, because I've come very well prepared. So this is an interesting one, and this was always a bit baffling to me, and I do not pretend to know all about this stuff, because for me it's I find it mind-boggling in certain aspects. But in the Code of Practice book, again for grid connected solar PV on page 71, we've got a section here called Earthing of accessible array frames. So I'll just read this it's only very short. Where the PV system is connected to an installation for which PME conditions apply, and where the PV array is generally accessible, for example, ground mounted, a local earth electrode shall be provided at the array location. The electrode shall be provided in accordance with BS 7671 section 542.2. The electrode shall be bonded to the building's main earthing terminal and also connected to the PV array earth frame. And then there's a little picture here where if it's like a timber ground mounted system, like if it's timber going into the floor or some other, some sort of plastic, I suppose, anything that's non-conductive, then you would need an earth electrode down. If this is on a PME system, an earth electrode down into the ground with a fly lead off it from the panels into the earth electrode. If it's a steel frame, then it's kind of earth through that. But it's still saying we would need an earth conductor back to the main earthing terminal of the building. It's saying here earthing on ground mounted arrays should be done according to the site specific earthing design, considering DNO requirements, soil conditions, fault levels, and construction methodology. Which is, for me, is a bit like, we've told you this, but you're going to have to still do a bit of digging yourself.
It's the cop out, isn't it? Basically, every little bit. I think it makes sense to have it. I mean, if you think of a ground mount system, most of the time your inverter would live near the panels. It's unusual, I would say, to be transporting the DC. I'm thinking of a bigger system. So if you've got a 100, 200 meter run, you might take the DC cables, but the losses you would get in doing that, it generally works out better, in my understanding, to take the AC back through that duct to the installation anyway. So a lot of those buried cable issues can be taken away by putting the inverter near your panels and transporting the AC. But if you're in that circumstance where you're not doing that, or it could be that you've got a really large array and you're moving strings between the rows and you're still burying elements of it, if you are earthing the armours of a PB Ultra SWA, is that much of a bigger deal when you're earthing all of the other things on that framework anyway? What is the increased risk from doing that? You've got all of your earth framework, you've got your PV cables cable tied to it, you've got your MC4 connectors all over it, you've got your solar panels clamped to it, and you're then distributing another cable between a row or two or back to an inverter somewhere else. Is it that big of a problem in that circumstance? And if it is, why? Not just that the regs say every buried cable must be earthed and we shouldn't have ADS alongside double and reinforced insulation. What is the actual risk in that specific circumstance? I think we need to get away from this black and white rigid, that is this, and more of a risk assessed approach, I guess. And we are kind of encouraged to do that a little bit. The regs are considered a guide more than an instruction book.
Yeah, they are. And I think one thing just to pick up on there, like with that big install we did, we actually ran the DC cables because one of the big issues that I think a lot of these big installs have is, say it's like a 50 kilowatt inverter, your conductor sizes are already quite large. You've got the 1% volt drop on the AC side, quite rightly, but you've got the 1% volt drop. So if you're having to run your AC cable out to the middle of the field, you maybe got 100 meters or whatever, you've got 1% volt drop to get all the way out there. So I think that's where getting the DC cables to be ran in the correct way, you've got a much higher tolerance on the volt drop of the DC side because it isn't linked directly to tracking the grid voltage. You've got a much higher tolerance on the DC side. So all the ones that we've done, we've much preferred to actually run the DC cables to a further distance than the AC, because otherwise we're having to supply like a 10 kilowatt inverter with like 50 mil cable or something stupid like that. So getting this right, there's like a couple of elements to it.
I mean, that's the other aspect of the regs with that 1% volt drop. There is a caveat to that where you can exceed that. So that's something else that installers maybe don't always take into account, that there is an allowance there that the writers of the regs have understood that's a bit of a problem in these large distances that you might find, and they've allowed that in there where you can go beyond your 1%. But it makes sense where you can install in a way to keep within that, then you might as well. So, no discredit to anyone who's doing that. I was just thinking of it logically from kind of an installer's point of view. I've never done a large ground mount array, I have to say that. I've not ever done one. So I'm just thinking off the top of my head how I'd approach it.
There is a point in this book somewhere, and I can't physically put my finger on it at the minute, but it mentions, and I might find it in a minute, but it mentions about if you are bolting your inverter to the metal structure outside, that you are then introducing it's not necessarily it's not in the class
No.
2 system that you're bolting to that ground mounted array. I will try and dig that out and come back to that. I'll go back to my extensive notes and see if I can find that.
Yeah, because I've seen installers try and get around that by building unistrut frames, but you still get the overlap in the massive earth anyway, so you would still get that. You'd have to go at least 10 metres away from your array framework, and that's where you sometimes see the green cabinets out amongst all of the... You see them in the field as you're driving up the motorway. They'll have them, and they're generally sited away from the panels, and it's to try and have that separation in the massive earth still away from that system to make sure you keep it as class 2. But it's the challenge of us as installers. We're not trying to shortcut anything. I think sometimes you see in the PV world where you might have your solar limpets and stuff that come out, and other things where people are questioning the quality and installation methods people are using to make more money. I don't think that's the case with this. It's people trying to be safer, trying to do things the right way, and looking to the industry of things for a bit more guidance on this and the way it's interpreted. Because all you seem to get back by default is, well, it's ADS for your AC and it's double and reinforced insulation for your DC, and you go off and figure it out. But that's not how the real world works. And if they're not careful, because we're deviating so often from what's in that book, where's the value in there for us as installers? You have to start asking those questions back at industry.
Yeah, I mean, what's quite clear is that Doncaster Cables have got a lot to answer for.
I don't think that. I mean, there's a use point. I would say to anyone watching this, my position on it is that you shouldn't bury that cable direct in the ground, earthed or otherwise. If you were running it in a 750N duct, there's an argument each way around for if you earth it or not. And I've asked some smarter minds than me for sure on this already. Craig on the Apprentice 1-to-1 podcast the other week, he was of the mind, and he won't mind me saying, that he would earth it. He would put it in a duct and he would earth it as well. And I was of the mind that I wouldn't. And that's just two conflicting views on a way to install based on interpretation of the regs. And I guess that's where we are with all of this. I think the worry I've got is that this is going to be adopted at scale. It's going to be buried direct in the ground. It might be earthed, it might not. It's going to be run up walls in people's homes as well, because people will see it. Oh, SWA don't need RCD protection. We can bury that in the fabric of the building. I don't need to run trunking or whatnot. It's fine. And you've got DC cables that don't have optimizers, that don't have rapid shutdown, and they're buried in the wall of people's homes, and we've got steel wire armour in there. It's fine, and it'll be all over. And I think the industry of things needs to get ahead of that and explain for installers to understand clearly where the use point for this cable is, and there is a use point for it.
Yeah, absolutely. I think trying to isolate that armouring in terms of access at both ends, I fall more on that side of it, that it's not accessible. You can't touch it. There's a different story if it becomes damaged, and if you're then touching it, if those armourings become exposed for whatever reason through damage, then it does, I suppose, become like an exposed part. But I think it comes again down to, what do we want to back these DC strings up with? Like the ground fault circuit interrupters, GFIs, are good, but I feel like the answer to some of these questions might be in the technology that shuts that inverter down. Because obviously, if we're shutting that inverter down, we're then disconnecting that positive and negative from the panels. It doesn't help if there's a short and that happens to be touching the armourings, and that's another element. And that's why I think optimizers are an absolute must, because you're shutting it down at source. But let's say it's a normal solar PV system, and we've got that ground fault, that GFI there, that is type tested, that has either to meet its functionality, either has had to have a functional earth through an armouring or through a separate conductor to a ground mounted array. I'm going to move off ground mounted arrays in a minute, because there's not a huge amount of people that are doing these, but let's just stick with it at the minute. If there's some sort of path that can monitor, there's the complications of the AC faults going onto it and all this other stuff. But I feel like the key to this is, how do we shut this system down in the event of a fault? It's okay us saying we need to isolate those armourings and we need to earth those armourings, but to what end? How are we going to stop this problem from getting worse? Like, what we want to do is we want to shut that system down if there's any sort of problem, and fast. Like you said, you want a big fault to energize something quick, to de-energize something quickly, so that it's then not a safety issue. A fault code comes up, ground fault ground fault on that. And so how do we get to that point? The armouring itself, I feel, is a mechanical protection, unless we think of another way to use it in terms of like a functional earth, or if it serves some purpose, it being earthed. If it gets damaged, I say it's ripped through the ground, either directly buried or in a duct. I agree with you. I think the duct provides the mechanical protection, 750N duct. And so you don't necessarily have to run an armoured cable, an armoured PV Ultra through that. But if a rock gets into that duct, or you decide you're going to bury it direct and it gets ragged on some rocks or whatever, and suddenly water's getting into that, and it might have gone, somehow through the armouring and into the inner cores, how are we turning that off? Solar Edge has got that fairly covered, and Tigo probably have as well, because they've got that monitoring ability out on the panels. But there's a lot of these systems going in that don't have that, because it is an extra cost on the install. And how are we going to stop those systems from causing an issue? And I feel like the key is we need to isolate. If we can't isolate the panels because we haven't got the kit out there, we need to at least isolate the inverter, so we're disconnecting that generation. And it's not going to kill that cable, which is the big issue. And I'm talking out loud here because I have not got the answer to this. This is why I think it's really important that we do start this conversation and get these more minds on it, because it's going to happen with more an adoption of these sorts of systems.
Yeah. What you described there, I mean, I know you use Solar Edge a lot, and you're kind of covering a lot of these potential issues off through just using that. They will see those problems. You will shut down at the panels. But you're dead right. A lot of installers aren't using that. They're using basic strings without optimizers. There are still the tools in the bag, though, that you can use. So if you get an inverter that enters a fault state, you can trigger a relay which would shut down sort of your Pro Joys that you've used before on installs. And they're 609473 compatible. So you could have that out at the array, and then a cable, again, running back to the AC system that shuts them down and turns off at source. So there's a way of achieving rapid shutdown beyond just optimizers. There are options there that aren't as expensive and maybe arguably easier to set up, and you have less terminations out when you're array, so that you can do things like that. But it's getting that message out there, I suppose. And I do think that comes down to CPD from the industry of things. And otherwise, we just end up with hearsay and installers seeing something on YouTube and thinking that's how it gets done. And before you know it, there's kilometres of this stuff in homes and in the ground everywhere. And we're reactively dealing with it rather than being proactive and explaining, okay, we've got this new cable type. We think X, Y, and Z, even if it's totally different to what we've just discussed here. We might be missing something entirely. We're not the experts, but I think we do need to have that conversation and that guidance on subjects as big as that. We can't ask them to niche down in everything. It's not paint by numbers with the electrical industry and the regs book, but big topics like that could have far-reaching consequences. I think we do need to get a bit more clarity on that. And fair play to Doncaster Cables for introducing the cable and yourself for causing all these troubles. I think it's something, but it is something that's been kicked down the road in the industry for donkeys. SWA and DC distribution has been going on forever, and it's still happening now. I'm sure with normal steel wire armour cables being buried on arrays out there, so we know it's going on. Why not deal with it? Get some education out there around it, and use some of the new innovation that's coming out. Make use of it. Don't be so quick to say not in the regs. We're not covering that. We're saying, well, it could be safer if you did. You need to be faster. This 5-6 year cycle lag is way too slow for the industry we're in. That's the fact of the matter. It's too slow. If they can't satisfy it quickly in that, look towards some of the IET. They had the IET 01. We've got the PAS document. Use other tools to get some information out there a little bit quicker to try and deal with some of it. Yeah,
I think something you touched on there is as through the course of this conversation, I feel like the key is to try and shut that system down at source, because like with my discussion point there about the GFIs, shutting that down at the inverter, you've still got that potential there on the cable if there is a problem and the positive and negative touching, and the touching onto the armouring, for example, which they might not do initially, and then they burn through towards it. You just don't know. And so I think something like the ProJoy stuff that we've both used, if you're not going to fit like a Solar Edge or a Tigo, or there's loads of different ones out there now, then something like that potentially has its own ground fault indicator, but you'd have to get a signal from the inverter because it's sensing that run, isn't it?
It does, but you could use a relay. That a lot of inverters have, is it DRC ports or whatever, dry contact relays. So if they see a fault condition, it can trigger that.
Yeah.
Which could open a relay and turn the AC off to the ProJoy. I think that setup's reasonably simple to achieve. And all of the technologies in that are components that satisfy the regs. They're all stuff, the 60947-3, your contactors. None of these are electronic parts. They're all mechanical. So I think there is an argument there to use it. But, whether they say it's acceptable or not, I don't know. But you look at it, if you imagine there's a problem in this this lighting conductor here, Sam, and there's a short in the wall behind me here. The light could go off, but the bulb blows, but that remains energized. Is what we want to happen is the circuit protected device to operate and shut that down to make sure that there's no current and electrons flowing around in the wall behind me here. And the same thing should be true for the DC systems when we're designing. We have the capability in the technology that's available to shut those panels down at source and stop voltages going into those strings when they've been nibbled, when they've been crushed, whatever else has happened. We can do it. The thing that's stopping it at the moment is the fact that it deviates from the regs and people are scared to deviate. Whereas if we're truthful, a lot of electrical installation certificates we complete, they're full of deviations in the box. If you use an EV Ultra, it's deviation. There's all kind of things we do where it doesn't necessarily satisfy what's in the good book. But as long as you can reasonably say, I think that's a safer outcome, I think that, people need to be confident in doing that.
Yeah. I wonder if it's a case of the industry moving and innovation moving in different areas at different speeds. So, like, obviously, PV Ultra is an innovation in how DC cables are installed. It's not the SWA side of things. It is a different subject as to what you do with that, but it opens up a question as to is the way that we're going to start protecting our DC cables different? Because the whole idea around the cable size, protecting the cable effectively through the short circuit that you can have across those panels, which is part of our design that we're using 4, 6 or 10 mil, depending on the string voltage and the short circuit current of that array of panels. I wonder if it's time now that where we're actually going, well, that's fine for an element of this, but we now need to maybe move on to protecting the cabling and the panels differently through things like a motorized disconnector like the ProJoy that is isolating those cables. Because yes, ground mounts are one thing, but let's forget almost SWA for a minute. If we're just protecting a normal cable that runs over a loft that's getting nibbled, are we just going to go, are we happy that that's going to be sparking and what have you? Like, some of these inverters have now got arc fault in, quite a lot of them have. It's not always activated. I think it's Canada is like one of the only places that has absolutely requested that that's turned on. We're now turning that on all of our Solar Edge inverters when we're doing the installs or servicing. But is it time that we tighten up on this now that it's becoming a bigger thing? Like, I think we discussed on one of the other podcasts, or I lose track now, but where, oh yes, it was the fire one with Luke. Maybe we're not seeing, maybe these solutions haven't come out yet because there hasn't been the problems yet, because solar is fairly in its infancy in the UK, or it's been around for a long time, but not the mass adoption, like you said before, hasn't really taken hold yet. We're still in that early stages. That actually we need more people to have more installations for then more regulation to come out. But like you've said, we're in the final couple of years probably before there's mass adoption, and all these problems haven't been addressed. And then we've got a lot of retrospective work to do to try and make them safer. And it's only going to take a few disasters for maybe that to happen, but we want to get ahead of that. A bit like the PAS document was very forward thinking. Maybe we need a new PAS document for the protection and automatic disconnection of the DC side.
You make loads of great points in that part, and I totally agree. I think we are kind of on that path now. It's the last chance saloon, I think, to really proactively impact things that are going to help. We're very reactive in the electrical industry, well, in all construction, really. If you look at Grenfell, is the standout one, isn't it? And, there's the Harvey Tyrrell case that happened. We had the whole plastic consumer units changing to metal. It's always after the fact. And I think we're at that time now where we can encourage much safer solar PV and battery storage installations through regulatory decisions that are going to affect some of those who are trying to install these things at scale and at a low price point. And there's a market for all of that, but there should be a bare minimum in standard. And my view is that should include BirdGuard, and it should include optimization, or at the very least rapid shutdown functions built into these arrays as a baseline in where the standard is. There shouldn't be this option not to do it, basically.
Yeah.
Is my view. I think that's what we need to start to get. But whether the industry of things sees that and the committees will discuss it, they'll bat those views around and come to a consensus that maybe they don't think that is necessary. But my view is it's the last chance, really, to try and get that in place, because we're going to see that up to 2035. We'll have a great big rollout in solar PV everywhere. And then we'll be left reactively dealing with the consequences of whatever we've decided to do.
Yeah, and I think obviously the biggest rollout of this stuff is in people's homes, really. There's obviously going to be big factory installs and all of that, but there's a big rollout in people's homes and new build. We're always shouting at new build companies to incorporate bigger solar PV systems, and the last thing you want on a new build solar PV, a new build property, is a dirty great PV Ultra coming down the outside. As lovely as it looks, last thing you want is this, £500,000 house with this DC cable that runs on the outside of the building because they didn't want to bury it in the wall. And that is another area which I think is a real tricky one, because if we think of the age-old thing, someone's putting a picture up and you've got a steel wire armoured or a normal PV Ultra, it's a case of you hit that in the right place, it's going to go straight through that. And it would do with an AC cable, but the difference is that the AC cable is tripping that RCBO in that board. The DC side is it just sitting there? How have you hit it? It can't be that ambiguous. It can't be that look oriented. We have to change how this is done. Like in that scenario of a DC cable buried in a wall, in that extract I've just read from this book, it says basically don't do it. Okay, well, what if we have to do it? Oh, you need to protect it. Right. Okay. But what happens if it goes through that protection? What is classed as decent protection for that? And for me, all these points that we're talking about come back to a way to shut that system down if it sees that problem. We've got the GFI at the inverter, but that's almost too late. We need something at source. I think it's in Ireland they have to have those like ProJoy.
They do.
We're not sponsored by ProJoy. That's the only one that we have used. But they have to have that at the entrance of that cable to the building. And I think it's a really good idea. If you haven't got, I know the optimizers don't necessarily meet the same mechanical BS number that you mentioned for the isolation, but something that either does it intelligently through the optimizers of the hundreds that there are now, or through something like the ProJoy unit that is looking for that fault state either from the inverter or does it in a way through its own monitoring somehow. That has to be where this goes, in my opinion, because whether or not it's a steel wire armoured or not, we have to change how we're just letting energised cables just sit there waiting for someone to touch them.
And that's where these discussions go. I mean, the innovation of that cable has led us to that. We're looking at it buried in a duct or whatever, but you're dead right. There's lots of cable installation methods used in people's homes that don't have any armours on them, and you're just as likely to see a fault state entered that is going to be undetected. It could be a positive leg of the strings that's in the loft that's been chewed by a rodent and been left exposed there for the next time the customer goes up to get the Christmas decorations out. It could be that up the side of the house you've got an issue, or that someone's decided to bury a cable in a dwelling, and all these faults are there but not detected, not shut down, left waiting for something horrible to happen when methods exist to see it and shut down. Because like you say, the inverters are really sensitive to these things now. If you put a nail through one of the strings, they're going to see that insulation break down. They're going to understand that they're monitoring the IR in the strings continuously. They can shut down. They can tell the optimizers to turn that leg of the array off, the string off, and you're back into a safe condition. All of a sudden, the customer's on the phone to their installer because the system's not performing right and they've got a flashing light on their inverter. Their app's telling them something's wrong. That is a way better place to be than somebody encountering live DC cables at 400 volts, putting themselves or other people in their family in danger. And maybe the innovation from this kind of cable, we could look to start using it in dwellings up into lofts. I'm thinking of that cable you've described. Why not use a steel wire armour PV Ultra to run up the edge of that building to offer some additional mechanical protection for if somebody hits it with steps or if some keen squirrels get up there and start trying to rinse all the insulation off it. There's a use point for it in places other than just chucking it in the ground. And I think it's needed. I think it will help. And I'm not in any way financially connected with Doncaster Cables or Sam. He's not paying me yet. Maybe if I keep going with this, he will. So yeah, there's no incentive for me there. I just find it interesting at a technical level. And that's why I enjoy discussing this with people like yourself. So I've had conversations with Stuart Cato about this as well. We've got an agreement from Darren Cranish from the ECA to come on and talk about this. He is Mr. Earthing and Bonding. For those of you who don't know, Darren, he sits on JPL 64. He writes a lot of the documents around earthing systems. He has his views on this. I won't tell you what they are here, but hopefully he can come along and shed some light for us on these subjects.
Yeah. That would be great, because I think if you've logged into this podcast thinking that we had the answer, sorry.
We just have our views, don't we? That's all we've got. Our views as installers. This is what these are, and that's why I hope that's useful to other installers out there who may be thinking, well, how can we actually use this stuff? Or customers worrying about taking cables across their garden lawn. What is an acceptable way of doing that? Because they're having methods suggested by their installers about certain ways of achieving it.
Yeah.
And also to the industry of things where they're thinking, well, what are installers actually dealing with out there, and how are they getting around these challenges, and maybe useful for them in some of the discussions they're having to come to a consensus in the way they guide us.
Yeah, what is clear is the guidance isn't there yet for that, for us to make like a unified response to what do you do with those armourings? How do we? But it has opened that question of, do we need to now, in the world of, on the AC side, we could see obviously the introduction of RCDs, AFDDs. We've focused quite rightly a lot on the AC side of the system because most properties didn't have anything DC in. Certainly like circuitry, they might have had appliances like we are seeing now with DC in, and that's been addressed through the types of RCDs and RCBOs that we fit in. But maybe it's time we pick up that mantle with the DC side, because I think it's needed, especially if we're going to expect a lot of these systems to be put on new builds where it's going to be hidden, or even just renovations where they're spending thousands and thousands of pounds. Last thing they want is that cable running down where their brand new patio is, and they can see it and they think, oh, it would have been nice if we didn't have that. And that maybe pushes installers to do things that they don't want to technically do, but to keep the customer
peer pressure.
Peer pressure. We've all faced it. And actually just run it and go, oh, that'll be all right. That'll be all right in that wall. No one's ever going to drill that. And next thing you know, something's happened. It might be the 100th one that you've done. That it's like that. And then suddenly you think back to all those other 99 that you've done and think, oh my God, are they all going to start doing this?
Yeah, I mean, that's the thing, that particular homeowner lives in that property at that point in time, but in 5 years they might not. Could be someone else. They don't know that cable's there.
And your name's still on the ticket.
Don't have that relationship with the customer that you do have. So I would say, I mean, we all get it, peer pressure, where a customer will be like, I don't want my lawn dug up. I don't want that wall opening up. You're not running cables there. But I want 50 solar panels on my roof. I want a load of batteries to run my house. Get on with it. And you're like, okay then.
Yeah, that's it. So I think we do need to open this conversation up. This is kind of an opener. We could have, I'm sure this, I'm hoping, to be honest, that this topic will be one that is discussed a lot in industry on this podcast for 2025, because you're absolutely right. We're at that precipice now of like, we need to get some of these really fundamental things sorted. Otherwise, we're going to have big systems, small systems, not knowing where they fall, and that ambiguity causes people to do what they think is best, which they think is best. But is there things that they're not considering that the industry needs to kind of display to us as technical people? But we can't be technical in absolutely every area, even in our own specialism. Yeah. So we need that collaboration. Again, it goes back to what this podcast is about. it's having these big conversations so that people in regulations like IET and some of these other, governing bodies and what have you, can see and maybe hopefully listen to this, see what installers are worried about, because they might just not think this is a problem, and actually go, right, okay, this is actually a really interesting point. We'll do this. And actually installers that don't listen to this podcast and that don't interact with a lot of stuff, but maybe have their NIC, NAPIT, whatever assessment, suddenly get talking to their assessor and go, did you know now you can do this, that, and the other?
Yeah.
And if we can have a small, tiny part of pushing that, then I think it's absolutely worth it. And I'd love to have people on to discuss this point and try and force something through, because, like you said, there's a lot of installs going in new builds and everything else. Might only be 2 panels on the roof, but still that risk is there if they're putting those DC cables within the wall, and there's no real protection or rapid shutdown on those cables.
I mean, we're quite selfish in our specialism that we want in the industry of things to give a lot of attention to this, because they have a big oversight on loads of topics all over the place. But this is the big emerging part of industry at the place people sleep at night and live. It's the innovation that's happening. And I appreciate you've got like highways, railways, airports, petrochemical, all this kind of stuff that they're dealing with. But, this is people's homes. And I think we need to get this right, and hopefully that they're on with it. I'm sure they are. I'm sure these conversations are happening. They'll be reviewing launches of cables like this and other things that are happening and deciding what they think is the right way forward. I just hope that comes out fast enough to impact, really, rather than it being too late.
Yeah, I agree. And yeah, I don't think there's, well, let's be honest, there's a lot more we can add to this. Like I've got a massive great sheet of this here about all sorts of different things, but to be honest, there's
given it a good overview.
5 podcasts worth of stuff that we can go through on
this.
We
can come back to it, can't we? We can take a bit of feedback, I think. I mean, I've about finished my views on this one.
Yeah.
Take a bit of feedback from the audience and go from there in the future, I guess.
Yeah, well, I want to do another podcast with you, because I know I've seen some of your stuff that you've put out, Mark, about PID and all this other stuff that is becoming more with the transformerless inverters, and all this other stuff is becoming more and more of an issue. So I think we've got another few podcasts in us with all of that sort of topic. So we'll probably scatter those through this year, and probably revisit topics like this as more information hopefully comes out about it. But just get that conversation going about all this stuff, because ultimately we can't hide from it, because someone's going to get hurt. And then who do we look to? We look at doing something reactively, whereas let's take a leaf out of the PAS book and get in front of some of these problems. Might not be perfect when it comes out, but let's get it started and start moving things forward. Yeah,
well said. Well said. I think I'm about all talked out. If you want
to
take us out on this one, mate. Not too much of a grilling. And for those who are wondering, there's a 10% discount code, Oval10, for your PV Ultra.
For every 10,000 meter drums sold. But no, thanks very much, Matt, for that. It's a technical one, and it's always like a bit of a worry that we're going to miss something. But it's very, very interesting to get that conversation started. I'm really looking forward to pushing on with that throughout this year. But yeah, thanks to you as well for sticking with us through quite a technical one. But if you have got any views on this, the floor is open. Leave comments, questions, messages. We will feed everything back into this conversation. We want the answer. We don't have the answer definitively. We've got our views, but feed all of that information back. Ask questions to other installers. Let's get the conversation started on this topic and others throughout this year. But as ever, thank you very much for coming and watching the Renewables Podcast. And we look forward to seeing you on the next one. Please like, subscribe, all of that stuff. Let's push this podcast in 2025. And thanks again for watching.
So we're into 2025, Sam, and there's been a cool product launch from our sponsors at Proteus. And we're lucky enough to go along to their event and have the exclusive run through of this. But you've got one there. What do you make of it?
Really good. I mean, you would expect us to say it's really good, and I was really worried that it wouldn't be really good. So we've got a couple of jobs where we're going to use the new DB. So this is just the box. But firstly, before we open the box, because it's not actually in here, we've got this really cool template on the back. So if you need a template to see the size when you're doing a survey or before you're fixing it to the wall, then you've got this really good template on the back of the box. That's what we've got there. But we've actually got the DB here.
It's a bit of a change from the old one, I've got to say, in colour more than anything, and noticeable straight away.
Yeah, absolutely. And for someone that's been doing solar for a long time and running trunking next to DBs for a long time, the first thing that was drawn to me for this board is that it all sits flush, so the lid doesn't overhang. Because that's one of the issues sometimes with boards where you've got a big, maybe 100x100 trunking running over the top or down the side, and then you've got the lid there, and you forget about the lid, you put the trunking up to the side of it, and suddenly the lid won't go on. Absolute nightmare. But this is all nice and flush. The next thing is obviously the flush lid as well. So everything sits kind of within the contours of the board, which is really cool. And then we've got a huge range of knockouts, and we've got some big square ones on the back, as you would expect. I'll show you inside in a minute. Then we've got some behind the din rail.
Your favourites, I've got to say, Sam, you love.
I didn't know if to mention that, but I hate that route. But that's, other people do it. Then we've got some really good ones along the top. So we've got, it looks like a 40, 25, 20, 25, 40. It's a 40 or 32. And then we've got the same on the bottom there as well. So we've got lots of entries there into the DB.
You're never going to please everyone with that. And like Sam's just said, he's not a fan of those Instagram boards. I like doing one from time to time myself. And some electricians like plain boards. All these things are going to be in the range from Proteus as time moves along.
Yeah, and then inside the board, we've got plenty of wiring room there as well. And there's been a colour change on these, haven't they? They've got all of the switch gear the same colour.
Yeah. So of the past, it was a slightly different shade, and it didn't line up with the logos either between the MCBs and the RCBOs and the SPDs. Now that's all on point, and anyone with OCD like me will be very happy about that.
Yeah, absolutely. And they've got the main switch that they come with now has got the double terminal, which was that from a different range before?
Yeah, so that was in the M2 range. So they're all part of the IMD group, and they've popped that into the Proteus range as well, which is an absolute no-brainer for me, because the big failure point in consumer units historically is usually the main switches, isn't it? And having that extra terminal there just gives a bit of reassurance that it's not going to come loose.
Yeah, so for everyone listening, the main switch has got a double screw on each line and neutral conductor, so you're getting a double connection there onto the tails, which is really good. But to be honest, it's just a really good board. Space, they've got a great range of protective devices that a lot of them are single module, so you can make the most out of a smaller board. It's just got everything that you would need from a board, really, which is just really cool. And you've got obviously a little back entry grommet there as well to slip in if you're doing a board change.
We need to eradicate grommet strip from all of our lives sooner rather than later. That's a positive step in that direction. And the SPD as well now comes with those fly leads.
Yeah.
So of the past, you just used to get the SPD in and of itself, and some installers didn't like making up the leads to get from the earth bar down to the terminals there, and they're all in place now, so there's no need to be worrying about that. And equally, you can get the breakers onto the DIN rail with the bus bar in situ as well, because I know that's an irritation for a lot of installers, that sometimes you have to drop the bus bar to get your breakers in. And
it's not always that well known that the SPD can go directly onto the the bus bar as well, meaning that you don't need that extra MCB or whatever that's taking up a space, and it's single module as well.
Right. So to 100 amp supply, you're fine with that one straight onto the bus bar, and that front cover lid as well actually pops out. So there's a little retractable thing there. So if you're working on your board, popping your labels on or whatever, you don't need a magnet that can hold it up in position. It just clips out, and then you can take that out of the way while you pop your label strips on.
Yeah.
So it's a really, really nice board. Big step up for Proteus, I think, from the last range, and they should be available in your CEF branches right now. They're not currently on CEF online. We're at the start of January recording this. Hopefully by the end of the month it will be, but that's just the CEF of things. Has literally just launched yesterday.